All right. So we made our 6 cards. So again, we're putting these in there. Rest or stop means our velocity equals 0. Moving to the right means our velocity is greater than 0, and you need assigned charts. Moving to the left, our velocity is less than 0, and you need a sign chart. Speed, we said think of our speedometer. All of the numbers on your speedometer in your car are positive, so it's the absolute value of velocity. Speeding up is when we had to compare velocity and acceleration. They're going to have the same sign. You don't need to tell the grader what it is. You just need to show they're either the same or different. And make a sign chart. And then slowing down, our velocity and acceleration have different signs. Again, I'm going to make a note that you need a sign chart. All right, so just to kind of recap, this is a short week. We have Friday off, so spirals are due by Thursday. There's a good handful that turned them in already, but spirals are due by Thursday. You had test corrections due today, so if you still have those test corrections, they're due today. That'd be stapled to your test. So keep that in mind. Remember, they are zeros until they're in there. As far as the curved grade goes, only if all your work is done do you get the curved grade. All right, we're going to spend another day talking about motion on the straight line. And I think we left off, we did 123 for homework, right? Let's tackle, eventually. Just hold on to that because we're going to hit the back one of these moments here. I don't know if it's today or tomorrow or what, or homework. All right, let's try topic, let's see, page 122. All right, the following problems involve straight line motion. Unless otherwise stated, the functions model, position, velocity, and acceleration are continuous and differentiable. All right, so they give us, they say for t is greater than 0, so we don't have to worry about negative numbers, obviously time. Particle moves along the x-axis, and it's given this velocity, and it's given the what? What does x represent again? The position. So I know the position at 0 and I know the velocity. So the first thing it wants us to find is find the acceleration. So let's just recall, who do we start with? Position. And if I take the derivative of position, I get velocity. And if I take the derivative of velocity, I get acceleration. After that, that's all stuff from physics. This is all we do in calculus: position, velocity, acceleration. All right, so find the acceleration at 10. Right now I have velocity, so what do I have to do to this function? Take its derivative. So I want v prime of t. All I want to show the grader is v prime of t. Quick derivative, just the power rule. What should we get? 2t minus 8. And now I want that velocity at 10. So all I'm going to do is plug in a 10. So I'm going to get 2 times 10 minus 8, 20. Minus 8 should get me 12. Okay. Did they give us units? Doesn't look like it. All right. Part B. Find all the times when the particle is at rest. So there is the key. You got to find the key calculus word and then do whatever the back of your flashcard says. At rest. Who are we talking about when we're resting? What is our velocity equal to? Velocity equals 0. I have no velocity. I have no direction. Remember, velocity is about direction. So I'm going to set my velocity function, which they gave me, equal to 0. So t squared minus 8t plus 12 equals 0. Nice, easy trinomial. What are our factors? Good. 6 and 2, both negative. So if I t those up, I should get t equals 6 and t equals 2. So there are 2 moments in time when the velocity equals 0. Part C, when is the particle moving to the right? So that's right from our flashcard, moving to the right. And again, everything we hit on Friday. I'm moving to the right when my velocity is greater than 0. Now we also wrote you need a sign chart. Okay, and we talked about our sign chart on Friday. So I'm going to take when my velocity equals 0, which we already found here, 2 and 6. And I'm going to label this velocity because that's where those numbers came from. Okay, and then I'm going to plug numbers in. Now, we did have an endpoint because it said time had to be greater than 0, so I'm going to stop this at 0, but this obviously goes forever. Okay, so I'm going to pick a number between 0 and 2, probably 1. Again, there's an infinite amount of decimals you could pick, but 1 works. And I'm just going to highlight, we plugged into the factored versions because that, remember, we just care whether this thing is positive or negative. So if I do 1 minus 6, what type of number do I get? Negative. And 1 minus 2, negative. A negative times a negative makes a positive. So that tells me I'm moving to the right. Pick a number between 2 and 6, like 3. 3 minus 6 is a negative. 3 minus 2 is a positive. A negative times a positive is a negative, so I'm moving to the left. If I pick a 7, 7 minus 6 is positive. 7 minus 2 is positive. A positive times a positive is a positive. So there are 2 moments in time when this particle is moving to the right, and I need to name them. From 0 to 2.
Do you put a graph around the 0?
Nope. Because yeah. Actually, we probably could because, well, it depends, right? It is an endpoint, and it's equal to 0. If I plug a 0 in, it's still a positive. So yes, let's make it a bracket there. And 6 to infinity, which will always be a parenthesis. And again, my justification, I put over here, but I'm just going to put next to it again. V of t is greater than 0. Okay, you're always going to say why. Okay, so we said anything about movement is velocity. Part D says find a of 3. So now I want to plug 3 into acceleration. Have we found acceleration already? Mm-hmm. Yes, right? That was up here in part A. So my acceleration is 2t minus 8. So I want to find a of 3. 6 minus 3 is negative 2. Second part of the question says, is the particle speeding up or slowing down at 3? So again, if I'm going to speed up or slow down, 2 forces have to act against each other or with each other. I have to compare my velocity and my acceleration. So what do I know about the velocity at 3 and the acceleration at 3? I just found out the acceleration is negative. Okay, the velocity at 3, I can go back to part C. What do I know about the velocity when I get to 3? The velocity is negative, reading that sign chart, right? At 3, my velocity is negative. So what is this telling me the particle is doing? Speeding up. Okay. So speeding up, since V of 3, and make sure you put the time in there, V of 3 and A of 3 have the same sign. I'm never going to say both positive, both negative. We're just going to use the phrase the same sign. V of 3 and A of 3 have the same sign. All right, E. So again, review from on Friday. Is the particle moving toward or away from the origin at t equals 0? So we want to talk about the origin, so where we just make a number line and we talk about here's the origin. If I want to know if I'm moving towards this number or away from it, I first have to know where I what? Where I start. Where is my position? So the first thing I need to know is my position at 0. 99% of the time they just tell it to you. Yes, the position at 0 is negative 5. They tell us here. So I'm going to put my little person here at negative 5. Or a bug. Yeah, I couldn't draw a bug. I went with a person. All right, so here I am at negative 5. And now I have to look at my what? Velocity. So I'm going to go to my velocity at 0. What is our velocity at 0? Positive. So that tells me I'm moving to the right. Okay, so I'm going to say V of 0 is greater than 0. V of 0 is positive, so I'm moving to the right. So that tells me I'm moving towards the origin.
How are you getting that it's positive without actually solving?
So I did kind of solve in my head. So I used our sign chart here. We included 0, right? 0 to 2. I could plug 0 into my velocity, and I get 12. Okay, so it's moving towards the origin, and this is really why. I'm positioned at negative 5, and my velocity is positive. You could literally say the velocity is 12 just by plugging it in if you want, but it's clearly positive. All right, they love this question. What is the velocity of the particle when the acceleration is 0? Okay, so my question is, what is the velocity, but I don't know the when part. when the acceleration is 0. So I first have to set acceleration equal to 0. So our acceleration function was 2t minus 8. And I want to set that equal to 0. What time does that occur then? 4. So I really want the velocity at 4. What is the velocity when the acceleration is 0? Well, the acceleration is 0 at 4, so I really want the velocity at 4. So all I'm going to do is plug 4 into my velocity function.
If you somehow got multiple answers.
That's a great question. So like if you had to factor this and got multiple answers, the question will be phrased differently. It'll say when the acceleration first equals 0 is usually what it says. And that happens a lot.
Like you don't ever have me find both.
No, it usually doesn't. 99% of the time says first equals 0. And then we can obviously crank out that math. 16 minus 32 plus 12. 16 minus 32 is negative 16. Plus 12 would get me a negative 4. What is the acceleration of the particle when t is 0? So we already found acceleration. We had that as 2t minus 8. And we want the acceleration at 0, so a of 0. I think so. And at what time is the velocity equal to 60? So I'm literally doing what it says. I'm setting the velocity equal to 60. So that was my t squared minus 8t plus 12 equals 60. Mason, who do I want to set this equal to? 0, yes. I'm going to subtract over that 60. It is 48. Negative 48? What is that? 4 and 12? T minus 12, t plus 4. I should get t equals 12 and t equals negative 4. Now, what does t represent again? Time, and what don't we have? Yeah, so we're going to reject that answer because, first of all, it said t was greater than 0, it's greater than or equal to 0, and time cannot be negative. All right, I don't think we tackled the calculator question last week, did we? All right, let's flip back to page 120 and grab your calculator. And this is a great review of all the buttons you have to be aware of on the calculator here. Just remember, in calc, your calculator should be in radian mode. So if you hit that mode button, you want to make sure you are in radian mode. Everybody got a calculator? You got a calculator? Okay, so it says from 0 to 2, a bug is moving along the x-axis. Remember, it's always on this straight line, and they're giving you the velocity function. It wants us, so let's first of all just get that in y equals. Okay, always get your function carefully in y equals, and you're going to use x, of course. Sine of x cubed. Take a quick peek that you typed it in correctly. Okay, just some other reminders, because people always like to slap the calculator here. If you want to get out of a screen, you just want to quit it. See, quit's in blue, you just hit second quit to get out of it. You don't have to hit the on-off button 10 million times, just second quit. It is a weird graph. All right, so the first part says find a of 0.7. So what do I want to do to this function? I want to take its derivative. Where do we find that again? Math 8. I want to take the derivative with respect to x. Now, we're not going to retype this function in. I think we talked about this once a long time ago. We pull up y1. Okay, so it's on the top row. Alpha, I think it's trace. And you just want to put in y1. You never want to keep retyping in because you're likely to make a mistake. So type it in once, make sure it's good. And now the calculator will take the derivative of whatever you typed in y1, and we're going to do it at 0.7.
How do you put in y1?
Alpha trace. Jot that down so you remember it for yourself. Alpha trace. Okay. So I'm going to say A of 0.7, and you're just going to show, this is all they want to see. It's worth an entire point. 3 decimal places. Negative point, does 921 sound right? To 3 decimal places? Yes. So I believe you can truncate or round up. Typically in New York State, we always round up. Truncate. So down in the South, they don't teach students to round. I don't know why, but they don't teach rounding. They teach truncating, where they just chop off the rest of everything. So they have to take both answers because the South doesn't teach rounding. Is the bug speeding up or slowing down at 0.7? So again, speeding up and slowing down. Let's start with our justification. What do we have to do? Velocity and the acceleration. So I also have to get the velocity at 7. Okay, now think about this. Where is velocity already sitting? y1, right? So we're going to pull up y1. And we're going to say of 0.7. So of 0.7. And it will do it for you. Just don't hit times 0.7. Make sure it's of 0.7. I've got negative 0.318. So now that I have the velocity and the acceleration, what can I say about my speeding up or slowing down? Speeding up. Now make sure you include the numbers. V of 0.7 and A of 0.7 have the same sign. Now, when you get to the exam, there's no like partial credit. There's no half credit. Everything's kind of worth a point, and it's either right or wrong. If you say V of t and A of t, you're implying the entire function, where this is about 1 moment in time. So make sure you put those 0.7s in there. All right. Find any values where the bug is at rest. So there's our keyword. What does at rest mean? Who? Velocity. Velocity is about movement, remember. Velocity equals 0. Now, let's go look at our graph. They also gave you the graph on this exam questions. Let's set our window appropriately. Just hit your window button. What is the x min we need to see here in x max? -1 to 2.5. And then the y's look like -4 to 3. Well, that's fine too. Yeah, I'm just ballparking it here. Okay. I don't want to see that crazy thing that you probably saw on Zoom 6. I want to make sure it looks like this picture. Okay, and mine, did I put, oh, I don't know, half that picture looks like it got cut off. Oh, because it says 2 in the directions. Oh, sorry. It actually says 0 to 2. Maybe I should read. It says 0 to 2 right there. So I'm going to use my x's to be 0 to 2 and fix my y's. Which now looks like the picture that I see there. Everybody good there? Okay, now remember, you are staring at velocity. This is the graph of velocity. So this picture comes to rest when my velocity equals 0. That is where this function hits the x-axis. This is when it hits 0. Okay, so we need to use the calculator to go get those values. Those are called zeros. So you have to go second trace.
When it's touching 0 at the very end, like near 0, does that count?
I'm not sure if it's touching. We'd have to double check that. It looks like it's close. I don't know if it's touching though. So give me 1 second. I'm going to use my 0 feature, second trace 0. Okay, just a reminder, we did this in Algebra 2 and Algebra 1, but here's what you do. You get close to your 0, so I get as close as I can. I have to do each one separately. And then you play this little left-right game. I have to go to the left, so I hit the left arrow a few times, then I hit enter. A line will appear. Then I go to the right side. A line will appear. That 0 has to fall between the 2 lines in order for me to get this value. Make sure you can get it on your calculator and round to 3 decimal places. Second trace 0. Play the left-right game. And I'm getting the bug came to rest at t equals 1.225. Make sure you can get it on yours. Okay, then I have to go get the next 0, so I play the game again. Second trace 0. And I first move my cursor all the way over to where I think the 0 is before I start the game. Okay, so I get close to it, as close as I can, and then I go to the left side and the right side. So I'm going to go to the left a few times, the right a few times, Make sure that falls between those two lines. You can guess anywhere, you don't actually have to move it, and I'm getting 1.801.
But it doesn't show the y equals 0.
It does, this is scientific notation. It's saying move the decimal 13 places to the left, and on mine. Due to pixel error, we might have all different scientific notations here, but it is 0.
But it's like a whole number. Why would it just not put 0 there?
It's just the pixel error depending on our, each one's probably a little different. All right, part C, find the open interval on 0 to 2 when the particle is moving to the right. So again, you're highlighting the calculus part, moving to the right. How do you justify moving to the right? Velocity is greater than 0. So you're going to start with that, and that tells you exactly what to look for. You're going to go to this picture of velocity and look at it to see when it's greater than 0. That happens to fall between my two what? Zeros. So that interval would be 1.225, comma 1.801 in between those two intervals. All right, letter D. Find the acceleration, so I clearly want the acceleration, when the velocity equals -1. So they don't come out and tell it to you, they're going to make you work for it. I first have to find when the velocity equals -1. So I want to see when v of t equals -1. Anytime two things are equal, make a reminder for yourself, you are looking for an intersection. You do a lot of intersections. Anytime two things are equal. So I obviously have velocity graphed. In y2, I want to graph -1. Okay, so velocity is already graphed in there. In y2, we're just going to put in -1 and then just hit graph because you already have the perfect window. And then go get that intersection. I have to find when those two intersect. So again, it's all under the same spot. Second trace. I'm not finding a 0 this time, I'm finding an intersection. Okay. It says, is this the first curve? I'm on the blue curve. And it says, is it the second curve? It jumped to my red curve. It will find the intersection that it's closest to. And I'm getting t equals 1.837. Everybody good there? So I want to find the acceleration at 1.837.
We can just do that math later.
Correct, but I'm going to do it on the home screen. But yes, that's all we're doing. So I'm going to quit out of this, second quit.
I also put that.
I'm going to take the derivative of my function in y1, because that's velocity. Okay, so just pull up y1 and then type your number at 1.837. So -28.877. So all the things you'd be expected to do on the calculator, the zeros, the intersection, and then just read carefully. It's all about finding that keyword and then going from there. That once you find the keyword and set up your justification, the idea behind it should be pretty straightforward. All right, let's switch to, I think we did 123 with homework the other night. Let's grab a calculator. One. Let's start on page 125, number 3. So let's clear everything out of your y equals. It says for 0 to 3, the velocity of a particle moving along the x-axis is given by this equation. So just carefully type that in. And again, we're going to use x is 2.5x raised to the 1.3 plus the sine of x squared. Okay. Now again, I'm going to start on a zoom 6. Every time I just start on zoom 6, no matter what. That clears any garbage out that was in my calculator. Yes, yeah. And then I'm going to change the one thing they told me. They said only look between 0 and 3. So I'm just going to change that window from 0 to 3. But I'm starting on zoom 6. Okay, always, always, always zoom 6, and then change the window to whatever it says. And we can see that whole picture there. So hopefully yours matches mine. So I'll give you a few minutes to run through, highlight the key word. write down your justification and then go find it. So in the calculator section, do not take the derivative by hand. You're doing it on the calculator. And there should be some answers to kind of compare with at the bottom as you're going. Not all written out, but. What are you trying to find?
The intersection of these two.
Intersection? Intersection. How you justify speeding up and slowing down. Correct. Everybody good on part A? Part B, how do I justify speeding up and slowing down? What do I have to compare? Yes, so I need to show the greater V of 2, and I need to show the greater A of 2. And then you can answer the question. Okay. So V of 2, again, velocity is already in your y equals. Just use the calculator to jot down its answer. A of 2, take its derivative. Jot down its answer. Then you can answer the question. So we need to find V of 2 and A of 2, and again, all on the calculator. How do those two numbers look? Okay, so again, y1 of 2, math 8 of 2, and now I can answer the question. What am I going to say about this particle? Speeding up or slowing down? Speeding up, since V of 2 and A of 2 have the same signs. Part C, is the particle moving toward or away from the origin? So you're, again, I would got to kind of draw it out for myself. If here's the origin, I want to, what do I have to first find? My what? I need my position at 2. And again, 99% of the time it just comes out and tells it to you. Where is it sitting at 2? At -4. It says it right there. So I know I'm here, so now I just have to figure out what my velocity is and where I'm headed. So we're going to finish that 125 for homework. Let's start there. We're going to finish just the front of 125, calculator active. So again, test corrections due, 1 page for homework, and spiral.